Okay, this topic I won't spend too much time on because it's very short actually, nothing much to talk about here. This deals with the equilibria involving pure solids and liquids. So what basically it comes down to the fact that when you have a system in equilibrium where you have a pure solid or liquid, their concentrations do not change in a reaction. And this can be mathematically proven, but again, I won't go into it here. If you have any questions about this, then please let me know. But basically, the concentration do not change during the reaction when you have a pure solid or pure liquid. So that has consequences when you write down the Kc or Kp value for an equation such as this, right? So in this particular reaction, we have solid calcium carbonate decomposing to form calcium oxide and carbon dioxide, and we have the back and forth taking place, and equilibrium is eventually established, right? So based on what we have learned, you would be tempted to write down the equilibrium constant as Kc is equal to the concentration of the calcium oxide times the concentration of CO2 times the concentration of calcium carbonate. However, because these two, as we said before, do not change, because calcium carbonate is a solid and calcium oxide is a solid, their concentrations do not change. So whenever we're writing the equilibrium constant for systems that involve solids or liquids, we simply ignore them and basically write down the equilibrium constant based on whatever is left, which in this case would be the carbon dioxide. So therefore, the Kc expression for this reaction would simply be equal to the concentration of CO2, all right? And that's basically how you deal with those systems. Any system where you have liquids or solids present in the system, you simply ignore them when writing down the equilibrium expression for such systems, all right? So that leads us to this example. You have this reaction here, all right? And the question is asking for you to write down the equilibrium constant expression for Kc. So you'll notice that there's a solid here, which is carbon. So therefore, we won't include that term in the expression. So the expression for Kc for this system, whoops, is Kc is equal to the concentration of CO gas times the concentration of H2 gas, all divided by the concentration of H2O gas, right? And that's it. And that's basically the equilibrium expression for this system. We do not include the carbon because it's a solid, all right? Okay, so we're going to stop here, and then the next topic is where we discuss equilibrium constants and what information we can get from them, when do we need them, and so on. All right? Until next time.